Hello there, welcome to our CPD tiling in wet rooms. I began life as a professional wall and floor tiler in the 1990s before circumstance saw me become a tiling assessor in 2006. In 2012 I joined BAL to become a member of the PST team or product support technicians before moving into a sales role in 2019. Following this seminar I'll be available for a live web chat to answer your technical queries, discuss your current needs or even to share experiences, but for now please let me introduce you to BAL. BAL were formed in the late 1950s as a result of changes within the building industry. BAL are indeed the world's oldest recognised tile adhesive manufacturer, and although BAL did not clearly invent tiling, the modern day industry and the products that we use daily were born in Stoke-on-Trent during this period. The catalyst for change was much as it is today. Changes within building methods and traditional tile fixing techniques clearly needed to be addressed. The tiling industry was limited tile fashions, tile sizes, tile types, and also limited with regards to the types of places and backgrounds to which tiles could be fixed. The British Ceramics Council was formed to investigate the need for performance building products which would allow the development of this limited industry. As a result of their investigations, a company was formed to research and develop the types of products required and to set in place methods and instigate working standards. The company name was Building Adhesives Limited, or BAL. Essentially, BAL were formed for the industry, by the industry. For several years, BAL researched and developed methods and products that the entire industry across the world now takes for granted. Polymer modified adhesives, primers, acrylic or ready-mixed adhesives, and the list goes on. This all came to fruition in 1963, where the first tile adhesives were produced in the same site that is occupied to this day in Stoke-on-Trent. And back then, as it is to this day, BAL continued to lead the industry with innovation and support. BAL has implemented a number of strategies in raw material use, waste reduction and energy saving, which has produced tangible results and led to the company being recognised as one of the top UK 6 manufacturing firms across all industries for sustainability and environmental management. We are committed to ensuring that environmental management goes beyond the recognised standard, continually improving performance and ensuring best practice methods are adopted at all times. We recognise the need to raise the bar and continually review environmental performance to identify opportunities for improvement. BAL ensures that the environmental ethos is carried through the product life cycle from material sourcing, product manufacturer, right down to consumer use. We strive to ensure that our use of raw materials is sustainable for the long term too. The review and revision of its purchasing procedures have resulted in 14% of all raw materials now being sourced from recyclable materials, with a target to increase this by 20 to 20%. The company has also worked hard to address the environmental impacts associated with transportation of raw materials and finished products, with 65% of all raw material suppliers now being UK based. Raw material use has also been reduced to the launch of new high yield products. 33 to 60% of additional coverings ensure that raw material use is efficient, responsible and sustainable, not only the benefits that this can bring to the fixers themselves. Improvements in packaging have also led to a sixth of all packaging containing 10% of recycled materials also, while 86% of packaging comes from UK suppliers. The implementation of energy reduction initiatives investment has resulted in a total energy saving of 147,000 kilowatts, or 6.4% of an estimated saving of 449.2 kilowatts per hour per annum. Additionally, BAL still continues to partner with Cool Earth, Europe's fastest growing environmental charity, to help fund the protection of rainforests in America. BAL support at every level, from the domestic right through to the commercial. M40 and M10 specifications as well as method statements can be written, ensuring that you get the most appropriate products for the project. We also have an online specification tool called PowerSpec. This is particularly useful for small projects where a quick and simple specification is required, or simply to check that you're on the right track. These services are supported by our technical advisory service, who are available during office hours Monday to Friday, and our training and technical team, who themselves are all time served tilers. Our TTSs are available not only to give technical guides but practical solutions too, and can be on site anywhere in the UK. So, here are our topics for today. The definition of a wet room, the history, the potential issues, design of the wet room systems and solutions, the overall design and aesthetics of the wet room, waterproofing products and systems, and as said earlier, will be available later on for a live web chat. So first and foremost, what is the definition of a wet room? Well, the Collins Dictionary says it's a type of waterproof room with a drain in the floor, often serving as an open plan shower. So where and when did wet rooms originate? As often we find these days, recent generations were not the first to develop these types of systems. It is often believed to be of Roman origin, but it was actually the Greeks who developed the first wet rooms many years before. Communal showers and open airs were initially driven by leisure and sporting competitions. The market in Europe has seen significant growth for some time. However, the technology required to achieve some of the more complex applications is fairly recent. Today we are more familiar with wet rooms in the original leisure setting. However, they are now more desirable in domestic application too. Tiles clearly have played a key role within these areas throughout history, but as we know, tiles alone will not protect the substrates, which is why the reason for waterproofing is so important and why the information within this CPD today is critical for a successful wet room installation. But as touched upon, they can be more complex and there can be some common issues if not designed properly, constructed and finished professionally. The focus on the surface finish as well as the functionality is often the benchmark for a client, although even a small crack and possible damage to the tile and grout can signify that something within the installation is failing critically, and the actual source of the issue can be much more serious and costly. In wet rooms, there is often a greater demand of water and sometimes from more exit points such as additional shower heads, body jets and of course steam. No longer a shower is a simple three-sided square box with intricate designs and additional features. There are potentially more leakage points these days, more corners, benches which are popular, additional pipe protrusions in their connections and seals, as well as complex drainage systems in their flanges. Leaks can also occur for a variety of other reasons such as insufficient or incorrect tanking material applied, the use of materials from multiple manufacturers which can often lead to incompatibility issues, and we have seen this in the past with the introduction briefly of bitumen-based tanking systems. Unnecessary strain being placed on the tanking system due to incorrect tile installation such as the omission of movement joints or failure to commission the heating system. Pooling of water often indicates inadequate flows which can add pressure to weaker areas. The correct installation of every element from drainage to tile is absolutely essential to a successful, functioning and long-lasting wet room. Unfortunately, water will always try and find the path of least resistance, and of course gravity will play its part on ensuring that water damages everything below if it gets the chance to. Any type of leak can often damage some of the water sensitive backgrounds and materials that we use these days, such as timber and gypsum based sheets and screeds. However, and more worryingly in the long term for these backgrounds, water will begin the subsequent failure of the substrate and ultimately the finish too. We will touch upon this several times during this CPD, but please be aware that water resistant materials do not restrict the travel of water in any way, shape or form. As mentioned in the previous slide, it's obvious to say that any type of leak can damage some of the many porous and water sensitive materials. The term water sensitive refers to how a substrate or anything that for that matter that would be affected in a negative way with the addition of water. Have a think of how many water sensitive materials we use in the construction industry today. Tongue and groove floorboards, timber joists and stud frames, plywood sheeting, plasterboards, plaster skim and anhydrite screeds would be to name but a few. If detected and remedied quickly, then the damage can be minimised. However, residual moisture may well start to cause unwanted problems such as mould build-up and fungus, which are often the early signs of water saturation and breakdown in water sensitive materials, especially those containing organic matter such as timber and gypsum. In the worst instances, water will also damage the very fabric of a building, and not to mention the issues with electrical components that may or may not be associated with the installation itself. Water resistant materials do not restrict the travel of water and can also be affected, possibly not due to swelling and change in shape, for instance, but water absorbed does need to come out in some way, and this can be experienced as hygroscopic pressure. To sum up the previous couple of slides, the first signs of an issue usually are a damp, dank odour, reoccurring mouldy grouts and silicons, even tiles. Water travelling to adjacent rooms, which is not uncommon to find mould on carpets and other finishes. Grout cracking due to swelling and background subsequently delaminating, and tiles delaminating, which of course, as we are all aware, that can not only damage expensive fixtures and fittings, but sadly people too. Water is carried away via a drain or drains. However, if the correct drain is not selected, then the application is put at risk of blockages. Organic materials can gather in the lower drain base and be difficult to clear. If you can't clear the drain out because of limited access, then the issues will continue indefinitely. The lack of or blocking an odour trap can lead to nasty and lingering smells, especially if not cleaned out frequently. It is also hugely important to pay particular attention to the rate of drainage, and to put this into more simplistic terms, the rate of drainage must exceed that of the rate of the head of the source of water. And lastly, it is also important to specify a drainage which is not only compatible with the finish type, but the waterproofing too. Cracked tiles or grout are often a good indication that something else is not quite right with the construction. Poor construction, which can lead to the inability of a tile background to accept both static and dynamic loads, often caused by poor construction choice of materials. Background swelling and deformity, which directly associates to thermal and moisture movement. Tiles not fully supported or solidly bedded with adhesive, where voids below a tile can restrain water, which means that bacteria, mould and smells can start to form and can be usually seen through grout discoloration via dark and damp patches or efflorescences. No waterproofing behind the tiles allowing water directly into the substrate materials is normally the best way to begin the deterioration process and subsequent failure. Unrestrained board joints, where sheet boarding materials must be completely rigid. However, this is not the case if all boards aren't fully restrained. Screw fixing the boards at the correct centres and having adequate frame systems behind can help alleviate this. The lack of movement joints, perimeter joints, corner joints and abutments will restrain materials and place extra stress on an installation, whether it be a floor or a wall. Ultimately, these issues again can allow extra water penetration, and it also assists the breakdown of the full system itself and cause the full system failure. So to avoid many of the issues in the complex installations such as wet rooms that we've just seen, it's critical to consider and understand elements such as time, where even the preparation for a wet room can take a considerable amount of time compared to that of a standard tile installation, and the time to prepare can often take longer than the application of the covering or finish itself. The preparation materials choice is vital. They should be suitable for use, efficient and functional. The various trades involved will require coordination and cooperation. There may be a general building contractor, a plumber, a joiner, an electrician and clearly a tiler. The appropriate materials. Choosing water resistant materials will help enormously, however they will require some waterproofing to ensure complete protection. The workmanship and ensuring that all elements of the work are completed and checked for precision, and it's also worth noting that it's the tiler's responsibility to ensure that the substrates and preparation are correct prior to applying the finish. It is not uncommon for a tiler to undertake the majority of the preparation within the wet room. You must know the fundamental solutions. Continuous waterproofing. Fewer junctions and connections from which water or leaks can escape. Compatible drain to waterproof connections reduce the risk of leaks at exit points. Strong stable backgrounds and proper installations of the tiles provide longevity and ensure the performance of the materials used is not breached in any way, shape or form. And of course test and inspect during the whole installation process, because as mentioned a little earlier, typical repairs to a wet room can often be costly and very, very expensive and usually involve a full reinstallation. Clearly, it's fundamental that we select the correct and appropriate materials if we are to avoid some of the issues, such as the ones discussed previously, and it's also important to avoid some of the misconceptions within the industry too, which will help you understand for the need of such materials. Unfortunately, there are a lot of terminologies out there and we do get confused by some of the definitions, but let's have a look at them now. As mentioned a little earlier, moisture sensitive materials are clearly affected in an adverse way when they come into contact with water, such as timber or gypsum. Moisture resistant materials will tolerate water exposure but won't stop water moving. These backgrounds would include certain backer boards, blockwork, renders, sand cement screeds. Just to touch on the biggest misconception that surrounds this aspect of tiling, and that is that many people believe that tiles and grouts are installed in wet areas to protect the backgrounds. Yes, tiles will provide a durable and hygienic finish that is water resistant, but certainly not waterproof. The easiest way I personally know how to break down this misconception is to ask you, how do we mix grout, for instance? Of course, with the exception of epoxy systems, grouts are mixed with water before use, therefore how can they be waterproof? In short, if a material can be changed with the addition of water, then clearly it's not waterproof. Although there are some waterproof materials out there and they will prevent movement of water through the body of the material, such as prefabricated specialist materials, i.e. shower formers and sheets, often continuous with no board joints, and some tile backer board systems too. To be aware of these differences can clearly change the design. They're a critical aspect of the installation and are paramount to the successful of a long-lasting and functioning wet room. None of these listed are considered to be suitable substrates for wet rooms and wet areas, and certainly not without the addition of waterproofing. Even then, some of these are unsuitable full stop. OSB, MDF and hardboard are not considered suitable at all, and additionally, and for information, plywood was removed as a recognised tiling background for walls recently too. As you can see in this table here, without adequate protection, all of these boards can be adversely affected by moisture, and as tiling is a rigid finish, it is important that the backgrounds themselves are both suitable and stable. So it'd be fair to say that to move away from moisture sensitive backgrounds in their entirety would be the way to go, but for now they're still widely used and therefore the need to protect them is absolutely critical. Solid backgrounds or masonry backgrounds such as concrete and sand cement screeds are often considered to be the most suitable substrates for wet rooms. However, this does not preclude the need for waterproofing as they are still classed as water resistant. Anhydrite screeds are not considered suitable and therefore should be avoided altogether in wet areas. Here is a table taken from the TTA or Tile Association showing the expectations of weight capacity of various tiling backgrounds on walls. Please note that this information comes from their industry manufacturers, not the tiling industry. Tile backer boards and masonry backgrounds such as render are the strongest systems out there and will be the choice solution, but as mentioned earlier, we still have a habit of using plasterboards and skims. A plasterboard direct can be tiled without the skim and as such can hold 32 kilos per square metre when in sound and solid condition. This equates to a ceramic tile not exceeding 12 mm thick including adhesives. A plaster skim, which is a finish of type in itself, can hold 20 kilos per square metre, which is the equivalent of an 8 mm thick tile including its adhesive bed. It's also worth pointing out that a plaster skim will take 4 weeks to dry prior to tiling, and that the capacity given to us is also when the boards are in sound and solid condition, not when they are affected by water or start to break down. Changes within BS 5385 Part 1 saw that the use of plywood as a wall tiling background, as mentioned a little earlier, was outlawed in 2018. Plasterboards and skims, although not ideal, still can be used, but as mentioned are water sensitive. They can be waterproofed using the appropriate materials and providing they are strong enough to hold the tile chosen. Render can be made waterproof and providing it's in solid and sound condition has no weight limit. Tile backer boards containing materials such as cement, magnesium oxide or lightweight XPS are considered as a very good background of choice and would certainly be my choice these days. They're designed for tiling, can be water resistant or waterproof depending on the board, offer thermal properties, some have a fire rating, they don't swell, expand or contract when they come into contact with water, and they have a high capacity for weight, generally exceeding 60 kilos per square metre, and some manufacturers' products are also resistant to mould and fungus too, making them an ideal choice for wet room or shower room selection. None of these are considered to be suitable coatings for tiling in wet environments. Bitumen notably has been used within the tile industry as a tanking system of sorts. However, it proved to be unstable, and as it changes frequently, especially with the addition of modern day under tile heating systems, it proved to be disastrous. Paint, especially with the move away from oil-based paints, means that paint itself can often, or when come into contact with water, and is generally seen as even a barrier to adhesion, much like PVAs, which are misinterpreted as a tiling product within the industry. As a footnote, PVA is not suitable in any aspect of tiling and is not recommended at any point in any form. So there are many types of waterproofing systems out there, such as liquid applied systems, which are easy and fast to install, can be rapid drying to enable tiles to be installed quickly. Joints and penetrations are sealed at the time of install, but can be repaired easily if protruded or punctured. These types of systems vary from simple ready-mix systems to fast-setting stronger cement-based products. Sheet applied membranes, which can be fast to install but use cement-based tile adhesives and consequently primers on occasions, which means they are reliant on the cure of the adhesive before use. Always be aware that when puncturing a membrane for the use of a tiling batten or even cutting a hole for a pipe protrusion may avoid any product guarantees. These types of systems often use components for dressing pipework, etc. Pre-waterproof substrates such as tile backer boards, which offer excellent waterproofing, which are good for constructing both walls and specialist finishes such as benches, but they still require sealing at the joints and penetrations. Epoxy grouts. Using impervious tiles and epoxy grouts to create a waterproof surface, but as mentioned earlier, this does not preclude the requirement for tanking. Selection of the drainage and the way that water escapes via the drainage system is clearly key. Flows must be between 1 to 35 to 1 to 80. Fully integrated systems are commonplace these days and widely available, and not only offer functionality but can also form part of the design process itself. There is such an array of tiles available for choice that narrowing down to the most suitable can often be very difficult, especially when trying to meet the demands of a client who may be more interested in the aesthetic rather than the function. There are various elements to a tile, which we'll take a look at now. So let's consider the tile types. All ceramic tiles should comply with the requirements of BS EN 14411 of 2016, which are harmonised standards. Ceramics have a porous biscuit body, easy to cut and mainly found for wall use these days, as ceramic floor tiles have largely been replaced by porcelain. Vitrified tiles, which only absorb minimal amounts of water, are generally much more durable than a ceramic tile. A quarry tile is a typical example of a vitrified tile. More commonly these days we find fully vitrified or porcelain tiles, which have a low porosity rate, usually less than 0.5% water absorption. In fact, the word vitrification actually comes from the Latin meaning of like glass. For information, dispersion or ready-mixed adhesives are only suitable for use with porous bodied wall tiles or ceramics, but not porcelain in general. Use highly polymer modified cement-based adhesives when fixing porcelain tiles to walls and floors. Natural stone covers a wide spectrum of materials from the very dense, the porous, translucent, the light and the dark. For lighter translucent stone, a rapid setting adhesive should be considered along with the colour of the adhesive, as shading of the tile is possible. Resin agglomerate tiles are a mixture of resin and natural stone aggregates which can be susceptible to distortion due to incorrect selection of adhesives or even where the tile is installed. As with all tiles available, the quality does differ, and resin agglomerates are no different, with poorer grades using more resin and less stone, which heightens the risk of distortion. Resin-backed tiles, mosaic sheets and glass must be checked with the manufacturers to their suitability. Occasionally the tile adhesive bonding, the meshes or the backing themselves can break down when coming into contact with water, and the mesh is certainly susceptible to water damage. Tiles are tested for slip resistance using the pendulum test usually, and it is still the most widely used testing method for slip resistance. It is important that the type of surface covering is selected and is done so on the basis that it is suitable in wet areas and dry areas for both shoed and bare feet. On the left of this chart, you will see the slip resistance ratings. All tiles available for use as floor covering should carry a rating as part of the European guidelines. The recommendation is to go for something around 36. Fully integrated systems such as drainage and waterproofing should be checked for compatibility and performance for the system prior to the install. What type of system do you choose? What's the drainage rate? Is the flow of water or the water leaving the shower head higher than the flow of the drainage itself? Fewer joints in the waterproofing. And as I said earlier, test and inspect all joints and wells, as repairs can be very difficult and expensive, especially once the tiles are installed around and over the drainage systems. Choosing the correct drain is critical. They should be easy to maintain, as mentioned earlier, and provide suitable function depending on the application and the design of the fall. Some drainage systems are specifically designed for working with tiles, subsequently considering drainage from all levels, meaning water can drain from the adhesive layers as well as the surface of the tile installation itself. Choosing the right tile adhesive can be confusing with misinterpretations, etc., but let's take a look at the recognised classifications in use today. C, which is cement based, D for dispersion or ready mixed products, R for reaction resin, and this is where you find epoxy systems. Then there's some numbers. Number 1 for normal characteristics or basic functions. Number 2, improved adhesive, which meets the requirements for extra applications. Then some more letters typically. F for fast setting, T for non-slip, which can be beneficial when fixing larger formats or heavier tiles, and E for extended open time. Whilst these classifications are important, they don't always tell the whole story of how an adhesive can benefit the user in terms of performance and working efficiencies. Also be aware that the higher the classification doesn't necessarily mean it's the more suitable for the job. There may be several other factors which may impact on the tile fixing solution. Other factors may include examples such as fixing a large format tile, which means an adhesive with prolonged pot life and working time is usually important. Pot life, for instance, is the time a product has once mixed to used. Standard setting products may last up to 5 hours, whereas rapids may be as little as 30 minutes. The adjustment or open time is the time a product has once applied to the background. Using primers, for example, is a great way of extending the open time of an adhesive. As an example, some cheap rapid setting products may have as little as 15 minutes of open time or time to adjust, whereas a premium product may be able to offer up to an hour. These are the things to consider with today's tiling and leaning towards larger formats especially. Other factors may include the bed depth of an adhesive, which could be a factor again when fixing large format panels or uncalibrated stones. The choice of an adhesive may even come down to the working conditions such as temperatures on the day, or the need to deliver a fast track installation, which is another reason why both standard and rapid setting alternatives are available from most adhesive manufacturers. In much the same way as adhesives, choosing the right cement-based grout is also critical, and they also have classifications. CG for cement-based grout, RG for reaction resin or epoxy grout. The number 1 signifies it's a standard product with limited flexibility and limited bond strength. Number 2 means improved or additional characteristics with extra applications available. W for reduced water absorption and A for high abrasion resistance. Please note that resin or epoxy grouts must be used for areas that require extra levels of good hygiene and chemical resistance, such as steam rooms, saunas and spas, and of course wet rooms. It is massively important to understand the use of an area post completion and how maintenance is to be carried out. For example, if power washing is to be preferred or a preferred cleaning method, then again epoxy grouts must be used. In this section, we need to ask ourselves, what is the design layout of the room? i.e., is the entrance point situated away from the direction of the shower? Is the area a traditional shower or wet room? Is the shower positioned so that water is encouraged towards the drain? Who is using the shower and what are the requirements in terms of access and usage? How is the humidity and moisture to be controlled in the area? What is the type of ventilation required? Is the transition between the wet and dry areas adequately accommodated? Are there any trip hazards or step transitions? For reference, BS 5385 Part 4 is a standard which refers to special environments such as wet rooms, saunas and even swimming pools or fully immersed environments. The use of underfloor and under-tile heating systems is becoming ever more popular these days, so as part of a wet room or shower area it may be necessary to consider the heating provision, which may be a traditional water-fed system, usually found within solid floors and screeds, electrical cable systems which can be installed by the tiler themselves as well as an approved electrician. But the advantages are such that there are no visible heat emitters, fewer radiators, more space, creating an open plan living environment, the even spread of heat and fewer hot spots and cold spots, generating gentle controllable heat and more controllable for zonal heating too, potentially low running costs when you're using renewable energies. When working with heat sources, it is important to consider these points and how stresses due to heating can be managed. The coefficients of thermal expansion, how the subfloor versus the flooring moves, minimising thermal and shrinkage movement stresses, the correct placement of movement joints, choice of adhesives and grouts. But in further detail, it's important to understand the effects of heat and how it affects the products within the entire installation, which could even include the tile itself. For example, a resin agglomerate which we mentioned earlier can distort when heat is present. Floor covering versus a substrate. Know how the substrate will react when heated and cooled, i.e. timber versus tile. For example, we know that timber will move with the addition of heat, whereas tiles barely will. Clearly there are multiple manufacturers offering different types of system today, so it's important that we know whether it's indeed suitable for tiling. Cabled electrical, wet fed within a solid screed, or overlay systems, which I would suggest to always contact the relevant manufacturers and their guidance before installing upon. Commissioning the underfloor heating system is hugely important not only for the screed, but on completion of the tile installation itself, as a lack of commissioning can cause cracking and delamination through initial expansion and thermal shock. Other considerations and factors to consider would be, where is the heating going to run from? Is it a conventional system? Is it renewable? Is it a ground source or air source heat pump? The need for movement joints is also more prevalent within a heated floor too, and clearly more critical given the extra stresses now placed on a tile installation. Always make checks as to the substrate prep and as to the suitability of the tile or stone prior to the install, and don't make assumptions that all tiles can be used. Uncoupling membranes are considered in most situations these days where tiles and stone are installed, especially when the stresses of heat are added. The consideration of an uncoupling system should always be there when limiting the amount of lateral stress, and it's more important than ever before, not only because of heated systems, but because today's tiles, with larger formats and narrower joints, means that tiles themselves have fewer places for movement and vibration. Highly polymer modified cement based adhesives, not just flexible but also make sure they have the correct setting times and characteristics for the install, as well as highly polymer modified cement based grouts. Again, are they the right smoothness, are they the right colour to pick up tile elements or the fixtures and fittings. Movement joints installed or located correctly in line with BS 5385 Part 3, which also need to be considered for both design and performance too. These are examples of under-tile heating, both wet-fed and cabled. There are multiple examples as to how an install can take place over such systems, depending on the manufacturer of the tiling solution, but it's advisable to discuss the installs with the manufacturer of a complete solution so as to avoid compatibility issues. But let's take a quick look at some of the projects we've been involved with over the years. The Huddersfield Leisure Centre, where BAL played a crucial role in the development of the leisure centre with its 12,500 square metre, £36 million development in West Yorkshire. The Huddersfield Leisure Centre features a range of top sporting and leisure facilities, including a 25-metre competition pool, a 20-metre training pool with movable floor, and family leisure pool with interactive water features, water flume and sidewinder. The new centre was designed to meet the client's brief for a multi-purpose sporting and leisure facility for the local community, which complements the existing street pattern and contributes to the regeneration of the town and surrounding region. From the outset, BAL technicians were on hand, on site to provide specification support and give guidance on installing and suitability of the backgrounds for tiling. BAL tile adhesives, grouts, sealants and preparation products were all specified for the project, which featured more than 10,000 square metres of tiling in the main changing rooms, upstairs changing rooms, pool surround, leisure pool, main pools as well. BAL products used at the Huddersfield Leisure Centre included numerous preparation products such as BAL Quickset Cement, BAL Quickset Render, BAL Prime APD and BAL Bond SBR, as well as the WP1 tanking system. A number of different tile adhesives were used throughout the project, including BAL Single Part Flexible, BAL Supercover Rapid Flex, BAL Rapid Set Flexible and BAL Max Flex Fibre. The Tate Britain. A stunning £45 million redevelopment of the Tate Britain made extensive use of BAL tile adhesives. The transformation included the Millbank project, creating new space within the national home to over 500 years of British artwork. Stonework specialists completed 2 packages in the Grade 2 listed building's southeastern quadrant on staircases and flooring, involving both new build and restoration work. As a major addition to the museum's former layout, a large opening through the floor of the main entrance rotunda allowed for a new staircase to be inserted. A further 2,000 square metres of flooring included a stunning geometric design that extends through the lower level of the museum, the canteen, public areas and lower rotunda. The flooring at the top of the grand staircase has a complemented fleur-de-lis pattern that echoes the design of the staircase balustrade. In addition, 500 square metres of agglomerate skirting, day doors and reveals were installed. A further 800 square metres of terrazzo flooring on the principal and upper levels and marble mosaic flooring in the entrance hall were also cleaned and repaired. The stonework contractor used BAL adhesives, having long experience of working with a professional's choice and its market-leading products and support. In particular, its valued support, namely the product support technicians who visited the contractor to demonstrate the correct use of the BAL stone and tile PTB product. The stunning redevelopment of the Tate Britain won the Tile Association Award in 2014 for the best use of tiles within the leisure and hospitality industry. Thank you for your time and thank you for joining our CPD tiling and wet rooms. Remember, if you have any questions or any queries or like to share any experiences, please join us in our live web chat after this session. Thank you very much and stay safe.